Alright, this is Geometry 3.5, parallel lines and triangles. Okay, so we have something called the parallel postulate. We have a line. We call it line L. This is the parallel postulate. We have some point P such that if I was to draw a line through point P, there's only one line that I can draw through point P that would be parallel through to line L. So for every point not on the line L, I can draw exactly one and only one line that will be parallel to line L, meaning I can draw a line. And drawing a line helps us a lot when we start to prove something called the triangle sum theory. We're dealing with triangles today. And the triangle sum theory says that the sum of the measures of an angle is 180 degrees. Meaning, I have some triangle, A, B, and C. This is the triangle sum theorem. Triangle sum theorem. I have these angles. If I was to add these angles, they will always add up to 180 degrees. Triangle sum theory. This is triangle angle sum theory. We're going to call it triangle sum theorem. Okay. Here is the proof. The reason why we did the parallel postulate is because we can draw something called an auxiliary line. And what an auxiliary line is a line that you can put into any type of scenario to help you prove a proof. So it's a line you can draw. To help you in a proof. A line you can draw to help you in a proof. That is an auxiliary line. The book says an auxiliary line is a line you add to a diagram to help you explain relationships and proofs. So we have this triangle. This is the proof of the triangle sum theory. We have this triangle A, B, and C. We have angles AB. They say, okay, let's draw an auxiliary line using the parallel postulate. So we'll draw a line P R. Okay. With this auxiliary line, we have three angles. 1, 2, and 3. We can say, according to this, we have this angle. I'm going to write it in blue. We have P, D, C. we have P, B, C. Okay. The first thing, actually, it should be 9 steps. So we have given triangle ABC, but I'm not going to get into that. It says draw. Actually, we are. I don't know if I can do fit 9 lines here. We're going to draw a parallel postulate. We have this P, B, and C. This forms a straight angle. We know that a straight angle is 180 degrees. So if we say that, we can say that PB line 2, angle PBC and 3 are supplementary. Definition of linear pairs. Then if they're supplementary, then they add up to 180. And we can say that PB and C plus angle 3 equals 180. Definition of supplementary angles. Then for the fourth line, if we look at PB and C is made up of angles 1 and 2. So I can use the angle addition postulate and say that PBC is equal to angle 1 plus angle 2. Then I can substitute angle 1 plus angle 2 for PBC, and I can say that angle 1 plus angle 2 plus angle 3 equals 180 degrees. Substitution, and that's what we want. Let's take a look here for a second. If I was to expand this line out here, if I was to expand this line out here, and if I was to expand this line here, look at the green line. We have parallel lines, right? We were told that they're parallel. This is parallel, this is parallel. And I have a transversal. And I have this interior angle, and I have this interior angle, and they're on opposite sides. So angle 1 and angle A are alternate interior angles. If I look at the yellow line, I have 3 here on the inside, I have C over here, also on the inside, they're on opposite sides. So angle 3 and angle B are also alternate interior angles. So I can use the alternate interior angles theorem and say that angle 1 is congruent to A, angle 3 is congruent to C. And if they're congruent, then they're equal. So measure of angle 1 equals the measure of angle A, measure of angle 3 equals the measure of angle C. Definition of congruency, congruent angles. And since 1 equals A, I can substitute. Since C equals 3, I can substitute, and I can say that the measure of angle 1 plus the measure of angle 2 is equal to 180 degrees. Substitution property. And this is the proof that the interior angles of a triangle are indeed sum up to 180. So we have interior angles and exterior angles. So they give us a triangle. We have angles, I'll draw it 1, 2, and 3. I can draw an extended line. Let's call this, I can draw an extended line. I can draw an extended line. Call this 4. Let's call this 5. Let's call this 6. I can draw an extended line out. Angles 1, 2, and 3 They're called remote interior angles. Angles 4, 5, and 6. They're called exterior angles. The interior angles are inside the polygon. The exterior angles, notice that they form a linear pair. Linear pair. Linear pair. Linear pair. Exterior angles are always going to be adjacent. They're going to share a common side, and they're always going to form a linear pair with that interior angle. So 2 and 5 are interior and exterior. They form a linear pair. 1 and 4 interior, exterior. 3 and 6 interior, exterior. They form a linear pair. Which leads to our next thing that says the triangle exterior angle theorem, which says that the measure of each interior angle is equal to the sum of its two remote angles. Okay, so what does that mean? We have a triangle the remote interior angles are the angles that are not adjacent to angle 1. So let's call this 4. 4 is sharing a common side with 1, so 4 is not a remote interior angle. 2 and 3, they're remote. And they're remote because they don't share a common side. They don't share a common side. So since they don't share a common side, they're called remote interior. So 1 is equal to the sum of 2 and 3. This is the triangle exterior angle theorem. The sum of the exterior angle is equal to this, or the exterior angle is equal to the sum of the two remote interiors, the ones that don't touch. Okay? So you can use that to do some mathematics and some algebra. You guys can do that. You don't need me for that. Again, this is more the same, applying. So if this is 80, this equals to 30 plus x. You can subtract 30 and get what that is. Pretty straightforward. Alright? And that's this section. Hope you have a great rest of your day.